Another calculation that we might care about is being able to determine the distance from some point in three-dimensional space, I call this point S, to some line. Right here is our line. And how do we know what a line is? How do we define a line? In this class, we're defining a line through some point on the line and a direction vector along the line. So given point S that's floating off in space somewhere, point P on our line, and some direction vector here, what is the distance from the point to this line? Now, it shouldn't take too much thought to convince yourself that this right here is going to be the line segment that minimizes the distance from S to this line. And how do I know what this line segment is? It's the one that is, we draw a line segment from S that's perpendicular to our line. So this is going to be all the possible choices go from here to here, here to here, here to here, here to here. This is going to be the choice that will minimize the distance from the point to the line. And so the question is, well, how do we come up with this? And I'm going to take this triangle, and we form this right triangle here. I'm going to pop this right triangle out of the picture. So PS, right angle. Okay, so how do we come up with this distance? Question mark once again. Well, let me make two definitions here. Nothing insightful. I'm just going to call this angle between the line, down here is the line, and the vector from P to S. I'm going to call this theta. And the length from P to S, okay, I'm just going to say it's the length of the vector from P to S. So using trigonometry then, this allows us to say that the unknown side is going to be, so the sine of theta is the length of the opposite side divided by the length of the hypotenuse. So a little bit of rearranging here, this unknown side is going to be the length of the hypotenuse, the distance from P to S, times sine theta. Okay, so this is what we have going on here. Now, so our job is now to find this quantity. And here's the trick. We want to think back to the cross product section 12.4. What do we know about distances and sine of theta? So if we remember, we should remember that in general, the magnitude of u cross w is equal to the magnitude of u times the magnitude of w times sine theta. And so let's call this u here. The hypotenuse is going to be u, and we have a vector that points along in this direction, v. V is the direction vector for our line. So the magnitude of the vector from P to S, this u vector, crossed with our direction vector v, is going to be magnitude of PS times length of v times sine theta. We're looking for length of PS times sine theta. I see a length of PS times sine theta. If we divide both sides by the magnitude of v, we have the desired quantity here, the magnitude of PS times sine theta is going to equal to the magnitude of the cross product here, PS cross v divided by the magnitude of v. So let's just write this formula as a theorem. The distance from a point S to the line through P parallel to V is D is equal to the magnitude of PS cross V divided by the magnitude of V. Okay, so this is a pretty useful little tool here. So let's apply this theorem. So let's find the distance from point S, 115, to line L, given by these equations here. So the thing is that we realize we need a point P on the line and a direction vector V for the line. So we should be able to read that off from these equations without too much difficulty. P will just be the constants here, 1, 3, 2. And V will be the coefficients of T here, 1, -1, and 2. Oops, sorry, I misread my own handwriting. 1 plus T, 3 minus T, and 2T. So let's correct that up. My apologies, that's a 0 there. So 1, -1, and 2. So we want to find the distance from 115 to the line through this point with this direction vector. So what information do we need? We need to find a vector from P to S, take the cross product of that with V, and then find a couple magnitudes and divide. Okay, so vector from P to S will be, so the entries of S minus entries of P. 1 minus 1 is 0. 1 minus 3 is -2. And 5 minus 0 is 5. PS cross V, I hat, J hat, K hat, 0, -2, 5, 1, -1, 2. And this crunches out. I'm going to skip the details. I encourage you to check this for yourself. But this crunches out as I hat plus 5 J hat plus 2 K hat. A quick check here. Again, check for yourself that this is orthogonal to this, and check for yourself that this is orthogonal to this. So now to finish the problem, the magnitude of this, the magnitude of PS cross V, is going to be the square root of 1 squared plus 5 squared plus 2 squared. That's 25 plus 5 square root 30. And the magnitude of V, square root of 1 squared plus -1 squared plus 2 squared. That is the square root of 6. So what is our distance? Square root 30 divided by square root 6. And that simplifies down to the square root of 5. So that's an application of this new distance formula that we have.